Welcome to HealthCast, the heartbeat of health IT. I'm your host, Melissa Harris. This year marks the 50th anniversary of the National Cancer Act, a bill signed by President Richard Nixon to empower the National Cancer Institute and to take on the war on cancer. To honor the passing of the act and the half-century of work NCI has done to make progress in the fight against cancer, HealthCast is partnering with NCI to bring you a mini-series of episodes throughout the year that highlight leaders from across NCI and work that the Institute has done in various areas around cancer. This episode, we'll talk about the history of the Act in cancer, as well as a high-level overview of what NCI has done in decades past until now to battle cancer. Dr. Ned Sharpless, the director of NCI, will speak with us today about these very topics and where NCI is today, including in its work with the Biden administration and First Lady Jill Biden. But first, let me explain a little bit about the history of cancer before we even get to the National Cancer Act, so I could help set the stage for how we got to the legislation in 1971. Cancer has long existed throughout human history. Evidence of tumors caused by cancer have been found in mummies, and records of cancer go back as far as 2625 BC, with records of breast cancer evidence in ancient Egypt. Despite that evidence, cancer didn't become a major cause of death until the 20th century. Most people died of other viral and bacterial diseases like tuberculosis, cholera, smallpox, or typhoid fever. But as science and public health got better, as well as the advent of the creation of vaccinations and antibiotics, we started beating those diseases and started living longer. Cancer, being a disease more likely to occur with age, took advantage of our longer lifespans to become a more prevalent disease. A 30-year-old woman, for instance, has a 1 in 400 chance of getting breast cancer, but a 70-year-old woman has a 1 in 9 chance. Most people in ancient societies didn't live long enough to get cancer, but by extending human lifespans, cancer flourished. According to Siddhartha Mukherjee's Emperor of All Maladies, between 1900 and 1916, cancer-related mortality grew by 29.8%, and by 1926, cancer became the nation's second most common killer behind heart disease. Dr. Sharpless will go into some of the scientists who innovated in chemotherapy, radiation oncology, and more innovations in cancer. But Sidney Farber, a pathologist at Boston Children's Hospital, was one of the key people who helped push for official federal support and backing to battle cancer. He was an advocate to combat childhood cancers like leukemia, and he worked alongside medical research advocate and champion of the American Cancer Society, Mary Woodard Lasker, to get the National Cancer Act signed after decades of advocacy. Although Farber and Lasker had been fighting for federal funding and support for cancer research long before the NCA, their work started to culminate in 1969 when Lasker proposed to the Nixon administration to form a commission on the conquest of cancer, which Farber was a part of. By winter 1970, the commission published a report, the National Program for the Conquest of Cancer, which pushed the administration to create an independent cancer agency with a starting budget of $400 million, then having its allocations increase by $100 to $150 million per year until the mid-1970s, where the budget would stand at $1 billion. A consequent bill, called the Conquest of Cancer Act, sponsored by Senators Ted Kennedy and Jacob Javits, was introduced in March 1971. To pitch the formation of a National Cancer Authority. In June 1971, a modified version appeared on the Senate floor, receiving 79 votes in favor and 1 against. After facing more pressure from the House for testimony and evidence, Representative Paul Rogers crafted a compromise cancer bill in November 1971, increasing the budget for cancer research vastly, but proposing to sharply restrict the autonomy of the NCI, a difference from the Kennedy-Javits bill. In December 1971, the House voted 350 in favor and 5 against, and the final legislation soon hit Nixon's desk on December 23, 1971, where he signed the National Cancer Act into law. The act flooded authorized money for cancer research and control, $400 million in 1972, $500 million in 1973, and $600 million in 1974. The Act made the NCI the agency as we know it and gave the authority it has today. Since the NCA was passed, cancer research and treatment has gone far. We have CT and MRI scans, more personalized treatment, and even started using cellular immunotherapy. Clinical trials have also improved, and NCI is using advanced technologies and data to carve its way forward. With all of this winded history in mind, let's go into my interview with Dr. Sharpless, where he'll color the last 50 years of work since the NCA was passed. Okay, Dr. Sharpless, thank you for joining us on HealthCast for this special mini-series that we're doing in partnership with NCI. How are you?
I'm good. How are you? Thank you for having me.
I'm great. So I just wanted to jump right into it and talk about the history of cancer. Cancer didn't really become a prevalent cause of death or even a prominent disease in the public eye until the 20th century. Can you go into that history a bit and how ad hoc strides to take on cancers like childhood leukemia in the 1950s and 60s led to the National Cancer Act in 1971?
Right. Cancer is a disease that predominantly affects older individuals, and in prior times in human history when people died at younger ages, cancer was not as common a cause of disease, although it was there even in, we've always had cancer with us, and particularly cancers that affect younger adults and children. But, with the success of other areas of medicine in the 20th century, we began to have increased lifespan in the United States, and cancer became a greater and greater cause of American mortality as other causes of death were addressed. And it became a real national interest. I think a really important event was in the 1940s and 50s, there was some very fundamental work that showed the development of drugs that could treat cancer, particularly childhood cancers, childhood leukemias, in fact. And then that led to the idea that these agents that could treat and sort of make the tumor shrink, if you combine them in just the right way, scientists at the NCI, particularly Tom Fry and Emil Freireich and their colleagues, showed you could actually one could cure certain forms of childhood leukemia. And these were very dramatic results. Before this work, those diseases were uniformly fatal in children. And then with multi-agent chemotherapy, it developed the National Cancer Institute in the 50s and early 60s. It became possible to fully eradicate those diseases, and the children would go on to have relatively normal lives. And then there was additional work in other kinds of cancer, certain kinds of lymphoma and choriocarcinoma and Hodgkin's disease, for example, where there was real remarkable progress using multi-agent chemotherapy and surgery and radiation. And that finding that one could now hope to cure cancer, it wasn't merely a problem where treatments would make the tumor grow more slowly, but actual cure of people with cancer, I think really was exciting to the scientific and medical community and galvanized the community and provided the idea that perhaps it was possible to cure other kinds of cancer, the common solid tumors like breast cancer and lung cancer and colon cancer. And so that led to this national desire to do that. And there were a number of important advocates who were interested in cancer progress, like Mary Lasker. There were some scientists like Sidney Farber, pediatric oncologist in Boston. And then there were some interested politicians who all came together to ask the president to sign a bill called the National Cancer Act in 1971 that led to this creation of authorities for a national, what they called a war on cancer back then, and which predominantly gave capabilities to the National Cancer Institute, including more funding, but also some special authorities to the NCI that really created a national infrastructure for cancer research that's been very important ever since.
You sort of got ahead of me there with a question I wanted to ask, and that was, there were a number of figures who were key in cancer research advocacy leading up to the NCA. You mentioned Farber and Lasker. Who were some of these key figures in NCI's books leading up to the NCA and its passing?
Sure. I mean, there's so many important people in cancer research. The whole sort of modern era of cancer chemotherapy starts with Paul Ehrlich, who, is more famous for developing antibiotics. But, he was the person who really had the idea that you could use a drug to sort of selectively kill cancer cells without harming the host. And he coined this term of the magic bullet. And that was, in like 1905 or something. It was very early in the 20th century. And there was no progress against that goal for, 40 years. But then a number of scientists developed multi-agent chemotherapy or chemotherapy drugs that would work and then that could be combined, as well as certain surgeons who, pioneered various surgical approaches to cancer that really improved dramatically in the early 20th century. And then also radiation oncology has been a very important part of cancer treatment. And so it was a combination of these individuals. So it was these great scientists like, Fry and Freireich I mentioned, and later Vince DeVita. It was these, terrific surgeons. It was radiation oncologists like Henry Kaplan, who, pioneered the treatment of Hodgkin's disease, for example, with radiation therapy. And then it was this important, group of advocates like Mary Lasker, Ann Landers, the columnist, was interested in breast cancer and childhood cancer, and actually led a letter writing campaign in support of the National Cancer Act, and many, many others. And it really kind of captured the national imagination, this idea that we could do something about cancer specifically. And that, as I said, really created a national initiative to improve outcomes for patients with cancer.
We've come a long way in the past 50 years. Over the past few decades, what do you think has trended in cancer research in as far as what has worked and what hasn't?
Yeah, so I mentioned, that probably the most important paradigm in the last couple of decades for cancer has been the notion that, each patient's cancer is in some ways unique, that they're all different diseases, and that every cancer has to be treated, in the context of that individual patient in a sort of personalized precision way. And so there's no sort of single approach to cancer, silver bullet for cancer, those kinds of things aren't realistic. What therapeutic approaches in cancer require, a constellation of approaches, including surgery and radiation and chemotherapy. Recently, we've added this other modality, boosting the immune system, so-called immunotherapy. So sort of fourth modality. But, it's really the key idea here is that you have these various ways to treat cancer. And the critical issue is to find the right approach for the right patient. So just because two patients have breast cancer doesn't mean you should treat them the same. And the therapies can be quite different based on the features of their cancer and the molecular genetics of their cancer. So that appreciation of the heterogeneity and diversity of cancer and the need to treat each of these tumors individually and differently using these available, successful modalities, I think has been, one of the most important advances in cancer research in the last 50 years. And it really is allowed, once we sort of bought into that paradigm, it's allowed us to really accelerate progress. As I mentioned, cancer mortality has been declining at a very steady rate over the last, 10 to 20 years, thanks to embracing really that view of cancer that every tumor needs its sort of own personalized therapy.
Technology, of course, is helping drive cancer research forward. What key technologies have been critical in the cancer research space since the NCA was passed, and what do you find to be the most pertinent today? I know you mentioned in our promotion that NCI SEER is really big, as well as some of your research centers. What technologies are they using, or NCI as a whole? What do you find is the most impactful?
Well, many things. So there's been the various technologies related to these therapeutic approaches. So, for example, better ways of making drugs or medicinal chemistry and drug discovery, or better ways of diagnosing cancer using radiology and other kinds of imaging and blood tests. And then, better ways of delivering radiation therapy, and that the planning of radiation therapies now is quite intensive from a computer computational point of view, for example. So those have, historically been quite important. And of course, the supportive technologies in medicine that allow us to treat patients with therapy, with the support of antibiotics and the surgical support and, modern blood banking and things like that. So, the ability to get patients through their therapy has been really, really important. I think in recent years, we've really started to see the entry of new computational analytic approaches to become quite important in cancer research. So now, we've gotten so good at understanding the genomic information around a tumor and many other features of these cancers that we've generated these gigantic data sets and now require very sophisticated computational approaches to really analyze those data and make sense of those data. And as important as those efforts have been to date, they're really just getting started. I think we're beginning to embrace, novel high performance computing and things like machine learning and artificial intelligence to really accelerate progress in cancer research and to use those findings in cancer research to develop new ways to treat and to prevent and to screen for cancer.
Speaking of data in clinical trials are some of the bread and butter of cancer research and advancements, and getting the infrastructure right for that can be game-changing in improving or accelerating those elements. What has NCI been doing to build a robust research infrastructure?
Yeah, you're totally right about that we've realized one of the most important things the NCI can do is create really great data sets of molecular and clinical data around patients and their cancers and make those data available to the scientific community. And if those data are very high quality, then the scientific community can use those data for all kinds of beneficial purposes for cancer research and for other kinds of biomedical research. So this has become a big part of the NCI's mission, is the sort of providing these great, well-annotated, useful data sets in a way that's maximally useful to the research community. And this is a much harder thing to do than it sounds. One effort we've had that has been very successful is this thing called the Cancer Genome Atlas, where we collected genomic information on, many tumors, thousands of tumors, and made those data available to credentialed researchers through a common online database. And now we've merged other of these sorts of databases to create this cancer research data commons that has a variety of kinds of data in it, being it genomic, RNA and DNA sequencing data, or it could be radiology data, imaging data, or it could be clinical information about patients' outcomes, for example. And we put those data in a format that allows them to be linked and analyzed simultaneously. And we make this available to credentialed researchers in the cloud so that, these questions can be studied by, with scientists taking a variety of approaches. But this is a problem where, the data really are key to making progress. And so figuring out how to provide more and better data for scientists and for, the clinicians taking care of patients is a constant topic of discussion at the NCI. And it's hard because there are, issues of data quality, and data collection is more expensive than one might imagine. And then also clinical information it has, this issue of we need to protect the participants' privacy. So clinical data has to be collected in a way that is beneficial to the research community, but also respects the anonymity of the research subject. So there are challenges to data collection and data aggregation, but there are challenges that the NCI has successfully solved for many years now and will continue to solve in the future.
Also, one innovation NCI has helped oversee is the Cancer Centers program. Can you tell me a little bit about those?
Sure. The National Cancer Center program was really created by the National Cancer Act of 1971. It's certainly in its modern form. I think we had some small centers that existed prior to the NCA, but they were nothing like the Cancer Center of the modern era. And what it said was that the NCI was going to support centers that were geographically dispersed, so spread throughout the country. And each of them was going to be, held to some standards, and they were going to get some funding from the NCI. And they were going to be tasked with doing great research, and usually in most of them also, great clinical research, so clinical trials and taking care of patients. And the idea was that we would have cancer research, spread throughout the country at many of these great academic institutions that have academic hospitals that work on cancer. And we'd also be able to take care of patients in the communities where they live and run, clinical trials that would, be relevant to the communities throughout the country. And it was a very successful idea. I think that for a number of reasons, some of which I already discussed, it's important to, not just consider cancer one thing that you study at one place like the NCI, but really, to embrace the heterogeneity of cancer and study in all its forms across the country. And this also brought a lot of new researchers into cancer research and increased the size of the enterprise. Also, the institutions, having a cancer center became very desirable. So because it was a sort of federally mandated center by the National Cancer Act, the academic institutions became quite eager to have cancer centers and therefore invested heavily in cancer research on their own. So they used their own philanthropy money and sometimes state monies to create cancer programs so that they would be competitive for an NCI designated cancer center. So that program has now grown to 71 cancer centers, and it's the well-known, most famous cancer centers within the United States are generally all NCI designated centers now, and they provide great care throughout the country, but they're also really important engines of basic science where some of the fundamental advances in cancer occur. And also, we task them specifically to take on the challenges of their catchment area, meaning the community they serve. So if they have a large African American population, we ask them to understand the issues of cancer in the African American population. If they have a large American Indian population, we ask them to understand the challenges of cancer in that population. If they have an area of significant poverty, then we ask them to address the issues of caring for a population where there might be issues about implementation and access to care. So the Cancer Center mission now includes this outreach and engagement portion where they really have to not only figure out how to address the problem of cancer, but address the problem of cancer for the community they serve.
It's also pretty remarkable for NCI that it got a personal visit from the First Lady herself. She spoke about her personal connection to cancer care and research just a few weeks ago, as well as her and President Biden's commitment to battling cancer. Do you think that that commitment will fuel further efforts or kickstart more innovation at NCI during this administration?
Yeah, I think to have an administration so interested in cancer research and cancer care and so committed to reducing the burden of cancer in American lives is wonderful. And it's very, I think, important signal to the cancer research community and the clinical research community that the federal government is interested in their work and wants to support progress for cancer as rapidly as possible. And I think this has been made very clear by this administration. Vice President Biden in the Obama administration was a real champion of cancer research and led the initial efforts to fund the Cancer Moonshot. And the First Lady has been a longtime supporter of cancer research and interested in cancer for a variety of reasons and supported, for example, breast cancer outreach efforts. And already we're like 1 month into the new administration, and we've had a visit from the First Lady virtually to the NCI, and then the Vice President and the President have both come to the NIH already, which I think is a very strong testament to the commitment of this administration to research. And that's really great to see. I think that the president is now speaking publicly about his desires to provide further resources for cancer research, and that would be very useful. I think that the sorts of ideas the president is espousing to accelerate cancer research can really make a difference.
And lastly, the fight against cancer is far from over, as we were sort of talking about. There's been lots of progress that's been made, but other areas still remain, a struggle. Where will research focus on moving forward based on these tough nuts to crack, sort of like pancreatic cancer and myeloma?
Yeah, I think that one of the hard things to talk about in cancer progress is that it's true to say two things at the same time. It's true to say that we've made a lot of progress. We really are seeing the last few years the largest decline in cancer mortality per year for a few years in a row now in the history of our cancer statistics. And record numbers of approvals of new therapies at FDA for cancer and lots of less toxic ways to treat patients. And so quite a lot of progress. But at the same time, while that's a true statement, what is also true is there are some areas where we really haven't made much progress at all and where we still have a lot of work to do. And in aggregate, we still, as I said, have 600,000 Americans die per year of cancer in the United States. So there's plenty of areas for progress. And so some of the areas that have been toughest have been diseases like pancreatic cancer and glioblastoma, brain cancer. These are two types where there's been very little change in the treatment of those diseases or the screening and prevention of those diseases. And the outcomes have really not improved much at all. And, how to make progress against these challenging cancers, I think starts with basic science. We really have to understand what makes these cancers tick at the biologic level and where the therapeutic opportunities are to either prevent them from happening or treat them if they do happen. But, one thing to notice is that this can change pretty quickly. I mean, when I started out in this business 20 years ago, there was really, melanoma and non-small cell lung cancer were sort of two of the most unimaginably bad cancers that there were. I mean, we had very little to offer those patients, and we had very little hope of how to treat those patients. And then with a number of new advances over the last 10 to 20 years, both of those diseases have seen sharp reductions in mortality and really improved outcomes. And so while we still have a way to go, we still have some patients dying of melanoma and lung cancer in the United States, it's much less than it was when it was seemed more therapeutically hopeless a while ago. And I think that that could happen in these other diseases too, as we improve our understanding of them and have new ideas and approaches. And there are many new ideas of how to treat something like pancreatic cancer. We just don't know if any of them will be successful yet, but there are certainly no shortage of concepts being advanced for these difficult problems. But that's really what one hopes to see, is that with a better understanding, we'll eventually see real progress against those diseases as well.
Yeah, that certainly gives us a lot of hope for the future. Just on a personal note, I've had much family that has, gone through some tough encounters with cancer. And I'm thankful that the NCI and the great doctors out there have been there for them. So I appreciate the work you've done. And certainly the National Cancer Act has made a lot of people's treatment and ability to get better possible. So thank you so much.
Yeah, I think everyone's lives has been touched by cancer. It's such a common problem in American life. And it's certainly an area where we've made a lot of progress, but we need to, commemorate this important anniversary and figure out how to make additional progress so that we can end this, the burden of cancer that is so troublesome in American life today.
Thank you so much, Dr. Sharpless, for joining us on HealthCast today.
My pleasure. Thank you for having me.
Dr. Sharpless is just one of our many guests we'll have for the next episodes of our National Cancer Act 50th Anniversary mini-series. Stay tuned next for our second episode, which will be on the progress of cancer treatment and diagnoses in late April. We'll be releasing episodes every other month throughout the year, leading to the actual anniversary of the signing of the NCA in December. Each episode will feature a topical area that NCI has been working on over the past 50 years, and will star NCI officials who are experts in those respective areas.
HealthCast is a production of Government CIO Media and Research. For more podcasts, head to governmentcio.media.com/podcasts. If you liked what you heard, let us know by leaving a review in iTunes or wherever you listen to podcasts. HealthCast is produced by Amy Kluber, hosted by Melissa Harris and Adam Patterson. If you're interested in sponsoring a podcast, contact us at sponsor@governmentcio.com.